Hello, coming from my itty bitty hallway today. I am going to do some review on some scientific notation. And if you can't see this, don't worry about it. I will take pictures of that and upload that later. Um, this is filming two. I had some issues yesterday with the Wi Fi. And so hopefully today this goes all good. I have some new, not new, well, some very colorful mouse ears on, some sparkle in there. Gotta get some good stuff. And let's hope that I have enough room because I have another piece of paper right here. So let's get going. Okay, scientific notation. Okay, let's start off with the basics. So C times 10 to the nth power. That is your most basic format. Now remember, C has to be less than 10 and greater than or equal to 1. Hopefully you guys can see that. And N, whoops, is an integer. Okay, so this is your basic format for your scientific notation. It's kind of a weird angle there. All right, so that's your most basics, okay? Now, in 10.5, reading scientific notation, okay? So I'm gonna do just a couple problems. I'm gonna do one of each when you have a power that's positive, when you have a power that's negative. All right, so we have 2 times 10 to the 7th. Okay, so remember your positive powers tells you that this number is going to get larger. Can you guys even see that? I don't know. Okay, this number is going to get larger because this is now saying 10 to the 7th, which is a 1 with 7 zeros. So what we're going to do is we are going to write this in standard form. So you're going to write this in the way that you guys are used to seeing. I can't figure out which way I want to stand here. All right, so we're going to go 2. And now we're going to move this 7 times. Do you guys remember which direction? To the right. Okay? So if the power is positive, you're going to move it 7 times to the right. If it's negative, you're going to move it to the left. So our decimals here, we're going to go 7 times. 1, 2, 3, 4, 5, 6, 7. And then you're going to fill it in with zeros. And remember, don't worry if you can't see this because I'm going to take pictures of this. So fill it in. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 2. Go back from the right to the left to find your commas. And our answer is 20 million. Okay. So 10 to the 7th times 2. And the standard form number is 20 million. Okay. So on this one, if power is positive, move decimal to the right. Because your number, C, is going to get larger. And there's half my face. I'm doing like a Picasso kind of a thing. Okay? So this number has to get larger if this power is positive. All right, so let's do one when it's negative. So let's go, I don't know, 1.35 times 10 to the negative third. Okay? So negative third power tells you that this number has to get smaller, and since our number has to get smaller, we then have to move it to the right. If we move to the left, sorry, we have to move to the left, pardon me, I was seeing that backwards. If you move to the left, that's going to get smaller, but if you end up moving this way on accident, this number 1.35 is going to get larger, which is the wrong way. So just, it's a way of checking yourself, knowing that, okay, negative power, this has to get smaller. So if you move your decimal the wrong way, check, did I now make this number smaller or larger than my original C? All right, so here we go. 1.35. We're going to move it 3 times to the left. So 1, 2, 3. So we have 0.00135. Okay. So remember that power tells you 2 things. It tells you the direction to move. So if it's positive, you move to the right. If it's negative, you move it to the left. And also how many times. Don't forget to check those notes that I gave you picture-wise for your composition book because they're in there as well. So negative power. C gets smaller. And over here, look at notes from comp book. have no idea what I'm talking about, they're all in your Google Classroom under composition book. I print off, not print, I take pictures of what I do and then I post them in there. Okay, because this is going to be just a very quick video on what you need to know for your quiz. Now, speaking of which, your quiz, I'm hearing that some people are still having issues with the Wi-Fi. And so what I'm going to do, I'm switching sides. So what I'm going to do is I'm going to prolong the quiz. I'm going to have it open Friday, and then you can take it through Sunday, just because I don't quite know when everyone's Wi-Fi issue is going to be fixed. And I want to make sure everyone has a chance to do it. All right. So that's 10.5 reading. I only did one of each problem. Remember, go back and check those notes from your composition book if you've been writing them in. All right, so 10.6. I'm coming back over here again. Keep changing sides. So 10.6. Now this is writing. So we're going to now take numbers and we're going to write them in scientific notation. And I need to get a problem. Okay, so I will do one of each. I'll do one that's less than 1 and one that is greater than 10. Okay, so let's go 163. All right, so the first thing you need to do is ask yourself, is this greater than 10 or is it less than 1? And hopefully you said greater than 10 because it is. So since this number is greater than 10, that tells you your power is going to be positive. This is so weird, only seeing like my eyeball. Anyways, and so on here, when you move the decimal, you're going to put all the way over to the right. So when you can't see a decimal, it's all the way to the right. And you're going to move it however many times you need to until you get to a number that's less than 10 and greater than or equal to 1. So here we go. If I move it one time, I'm at 16.3, and that's larger than 10. So if I move it again, I'm now at 1.63. And back up here, it's less than 10, and it is still greater than or equal to 1. So I have 1.63 times 10 to the count up how many times you moved it, twice, and double check. If it's positive, this power is positive, that tells you that this number C is going to get larger. If this is negative, that means this C is going to get smaller. And since 1.63, if we go back to the original problem, the end result is larger, that tells you that this power is positive. And they're good to go. But then if you have a number that is less than 1, so let's go 0.0245, whatever, I don't know, okay? And we're going to write that in scientific notation. So, since the decimal is here, you need to make sure that you move that to enough spots so that this number is going to be less than 10, greater than or equal to 1. I keep referring back to this because this is super, super important. So, if I move it this way, if I move it to the left, the number is just going to continue to get smaller, and we don't want to get it smaller. We want it larger. If I move it this way, then your number is going to get larger, that's the way we want. So if I move it just once, I'm at 0.245, which is not quite 1. So if I move it again, I'm at 2.45. And that's good, because now that's now greater than or equal to 1 and less than 10. So we have 2.45 times 10. Count them up. 1, 2. Oh, I did 2 again. Oh well, coincidence. Twice. Okay, now let's double check to make sure we got our power correct. So since this is 2, that's telling me that this number is going to get larger. But it didn't. It's actually smaller. So that tells you this is negative. Okay. So probably the hardest thing, or the thing you want to remember the most and when you write numbers in scientific notation, is checking your powers. And completely coincidence that I picked one that problems that have same, powers of 2. Double check. If it's positive, this number has to get larger, and it did. If it's negative, this number's got to get smaller. So that's what you really want to check. All right. Now, like I said, I will take pictures and I will put them in your Google Classroom so you can review those. Hope this isn't taking off my paint. Let's see, how centered is that? Hey, that's not bad. Okay, So 10.7. This is the one that we split up into 2 days, and this is what, like Picasso, half a face here. Or I just do like an ear. If you guys are wondering what these things are behind me, I'm going to show you here shortly. So 10.7, this is operations. And psi naught. Remember, psi naught, scientific notation. Okay? Who's our friend that helps us? Lars. Lars. We love Lars. What does Lars stand for? Left. Add. Right. Subtract. Okay? So remember, it tells you which way to move. So if you move the decimal to the left, you are going to add however many times you move that decimal back onto the power. If you move the decimal to the right, which we only saw once, but that's okay. If you move the decimal to the right, you are going to subtract however many times you move that decimal to the power. And we need to draw Lars. I'm going to make Lars a little bit bigger today. And what kind of hair should he? He should have, I'm going to try to draw a mullet. So business up front, party in the back. Yeah, that's looking good. I don't know, there's Lars. Okay? And helping hand. He only has 4 fingers today, but Lars is helping. All right? So I'm not going to do a problem for each type. I'm not going to do a problem of each type. What I am going to do is just go over when you need to change powers and that kind of a thing. So here I go again. When we add and subtract, I should have used different colored pens. That would have been more fun. When you add and subtract powers, they have to be the same. Okay? So powers have to be the same. Okay? And Lars can pop up in a couple places. Lars can pop up in when you are making the numbers in scientific notation and when you have to create the answer to be in scientific notation. All right? Now on this one, you do, when it comes to your base 10 numbers, you do not combine them. Do not. I need to work on my lettering. Combine powers. Okay? That was when I talked about kind of like, it's kind of, that power's like kind of like a common denominator, where when you have the denominator and it's the same when you're adding or subtracting fractions, you keep it. You don't do anything with the denominator because you're adding pieces of the same part, okay? So it's kind of like that when you're doing your operations in scientific notation. When you're adding and subtracting, you do not combine those powers, okay? Do not. But when you multiply and divide, you do. There we go. And I'm going to give you your extra credit question now, because some kids, I have figured out, go to the end of my videos to answer the question. So here's your extra credit question. The first 11 people who can respond to this on a remind will get extra credit. What is Steve's place of employment from Stranger Things? First, what did I say? 11? Yes, first 11 people to respond. So Steve's place of employment in season 3. You guys should have this. It's super easy. All right, multiplying and dividing. Here we go. I'm going to scoot this up a bit. Hopefully that's not taking the paint off my wall. When you multiply and divide, your powers do not. No. Need to be the same. Powers do not need to be the same. Okay? You don't have to make them into the same power. That's the kind of fun, cool thing about scientific notation when you're multiplying and dividing problems that are in scientific notation. I said that backwards, but you guys know what I mean. All right? But what you are going to do, you are going to combine these powers. Okay? Okay? So when you are multiplying problems that are in scientific notation, you are going to add those exponents. Okay? Multiplication. So if it's a multiplication problem, add the exponents. Okay? If it's a division problem, you're going to subtract your powers. Okay. And again, Lars will pop up. There's our buddy Lars today. He's got the mullet. Party up front. No, business up front, party in the back. Whatever. But I don't remember what that is. But anyways, I forget. So long ago. Anyways, so on your multiplying and dividing problems, powers do not need to be the same, but you do combine your powers. If it's a multiplication problem, you're going to add your exponents. If it's a division problem, you're going to subtract those exponents, and Lars does pop up as well. Okay? So there's not going to be much on this quiz. It's going to be a matter of like 10 problems, I think. And it should go fast for you, I hope. You can use any resource you have. So, you know, if you've been taking notes, that's great. Whatever. You can look at the notes that's on Google. I don't care. Okay? But it's going to be open Friday through Sunday. So now, if you've been wondering what the twigs are that have been coming out of my head, like these random little twigs. So Scott went to a reptile convention a little bit ago. Well, like 2 years ago. And he came home with this. Like, what is this? Like, look at this chin. Like, what? I don't even understand it. He's got button eyeballs. He's got, like, arms like Olaf. Look at this long nose. I don't get it. But he supports, you know, artists, and that's really cool, but dude, that thing is so weird looking. I just want to ixnay it, but he'll be like, hey, where's my happy guy that goes into the reptile room? Because he's like, this guy's called him the protector of the reptile room. Because there's the doorway into the reptile room. So he's like their protector or something. I don't know. So anyways, that's what's been popping out of my head. And hope you guys are well. I'll talk to you guys soon. Hopefully the Wi-Fi issues are all better now. Bye. Au revoir. Study. Whoops.